In section 1 here, we're going to actually focus just classifying and like properties of easy old school ideas of properties of triangles. Specifically, 2 ways to classify triangles: by their sides and by their angles. Classifying triangles by their sides, these are all review ideas. I'm going to zip through them pretty quick. A scalene triangle is a triangle that has all 3 sides different lengths. Isosceles has 1 pair of congruent sides. Exactly 1 pair. And equilateral has all 3 sides congruent. Because all 3 sides are congruent. Symbol for congruent. You can also classify them by their angles. By their angles. An acute triangle has all angles, or all interior angles, are acute, meaning less than 90 degrees. Right triangle has 1 interior angle is equal 90 degrees. Obtuse triangle has 1 obtuse angle one interior angle is obtuse greater than 90 degrees. And equal angular triangles have all interior angles are congruent. We're also going to discuss some different types of angles. There are 2 major types or classifications of the angles in our polygons, in particular, and specifically triangles. For our triangle, an interior angle is our first type of angle. Interior meaning the inside. So interior angles could be like this guy. Let's see if I can. I don't think this will be fine enough. Oh yeah, we can do that. How about like those highlighted angles are interior angles. The angles on the inside. Interior, inside. The issue, I guess, is going to come with the next type, which is, we're going to call them exterior angles. But exterior angles have a very specific definition. They're not just the ones on the outside. Exterior angles are angles formed in this fashion. They're angles formed by a side and a side extended. So we're going to call the angles we'll call exterior angles are angles formed by a side of our figure and another side that's been extended. So that's going to limit which angles are exterior angles. For example, here's a side of my polygon, of my triangle here. And here is a side that's been extended. So an exterior angle could be this guy. Could be an exterior angle. A side and a side that's been extended could be an exterior angle. A side and a side extended could be an exterior angle. This angle, this thing, not an exterior angle. This angle in here is formed by a side extended and a side extended. Does not count by our definition of an exterior angle. This is not an exterior angle. That's an angle on the outside, but it's not an exterior angle. This angle is exterior. This angle is an exterior angle. Exterior angle. Exterior angle. Side, side extended. Exterior angle. Side, side extended. Exterior angle. Okay? These little angles in between are not formed by a side and a side extended. Therefore, they are not an exterior angle. They're just an angle on the outside of this figure. The first one is one of the most important ideas about triangles that we'll see, and definitely the most useful one we'll see, well, probably period. We'll build a lot of things off of this. The triangle sum theorem. And it says simply that the sum of the interior angles of any triangle is simply (180 degrees). If you add up the interior angles of any triangle whatsoever, you will always get an angle sum to be exactly 180 degrees. So to explain why the triangle sum theorem is true, we'll just give an any old triangle, ABC, and we'll label it accordingly. We'll label it ABC, we'll label the interior angles so we can talk about them easier. Angles 1, 2, and 3. We want to show why, if we add these things together, you get 180. Here's a leap of faith that I wouldn't think that you would think of immediately. I'm going to construct a line that's parallel to the bottom of this triangle, wherever it is. I'm allowed to do this because we had what's called the parallel postulate that says that through any point that's not on a line, you can draw a line that's parallel to the other one. Right? We said that a while back. But again, it was a while back, so I wouldn't expect you guys to think about that right away. But you can construct a line that's parallel to any other one through a point. And we'll make it through this point B here. And it's going to be specifically parallel to the base of the triangle. That's going to be pretty important for this. Well, shoot, look at this. We get two more angles that have just been formed. Let's label those things. Let's be super creative and call it 4 and 5. Okay. We'll really get the creative juices flowing. Given this knowledge with the parallel postulate, from this diagram we can conclude definitely one thing. We can start by what happens if I add the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5. What does that have? What do those angle measures have to add up to, Dimitri?
180.
180. Why? Well, it's a straight line, and the sum of the straight line is 180. So if we add the smaller parts together, we should get the whole. Adding the parts to get the whole, we call that the angle addition postulate. We can add the smaller parts, we get the whole. So the reason why this is true is the angle Why is it true? Because if we add the parts, you get the whole. Angle addition postulate. Our goal, eventually, we're trying to eventually show that measure angle 1 plus measure angle 2 plus measure angle 3. We're trying to get here. Well, what could we do in between? What would be a nice relationship that would help us go from here to here? What would be one relationship we just love to have? Okay?
Measure of angle 4 is congruent to measure of angle 1 because they're alternate interior.
By construction, I've made parallel lines. So, oh, look at this. I have a Z pattern, alternate interior angles. Since they're parallel, what do we know about alternate interior angles? They're congruent. So therefore, 4 is the same as 1. Alternate interior angles theorem. Or if parallel lines, then alternate interior angles are congruent. What's something else that would be useful that we could then claim?
3 is equal to 5 because alternate interior.
Those are the same thing. Same as above. Because they're 5 and 3 are also alternate interior angles. So 5 and 3 must be congruent because of the alternate interior angles theorem. Or if parallel lines, then alternate interior angles are congruent. And do we have enough information now to claim that last statement? Yeah. And why can we claim this?
Substitution.
Let's make a clever substitution. And voila. Notice I didn't have any angle measures in here whatsoever. I didn't actually put numbers in. All I did was say that if I have 2 here and 1 there, then I deduce that they have to be 180 without actually plugging in numbers. So this should work for any triangle whatsoever. Now that we know that, now we could say, I don't know, find the measure of, say, the angles of this triangle. Well, we know that sum of the interiors are 180. So this right angle plus this angle measured x plus this angle measured x must add up to 180. I'll leave it to you to use some algebra to explain why x must be 45 degrees. But the triangle sum theorem says that you're allowed to create that equation. The last idea for today is something that's really non-intuitive. It's common sense, but it's nonetheless very important, which is a relationship between or amongst the exterior angles. The exterior angle says the following, and angle 1 here is clearly an exterior angle. An exterior angle in a triangle is equal in measure to the sum of its non-adjacent interior angles. What does that mean? What are adjacent angles? Angles that share a side? Adjacent? They share a side? Well, there are 3 interior angles of this triangle. Where are the angles that don't share a side, the interior ones that share a side with angle 1? A and B. This interior angle is adjacent. It shares a side with this exterior one, so we throw that one out. From this theorem, we conclude from this diagram that measure of angle 1 is the same as the measure of angle A plus the measure of angle P. Another word for its non-adjacent interior angles are what's called the remote interior angles. Remote, like a remote location is far away. It's somewhere off in the distance. You use a remote control to control your TV when you're not near the TV. You're far away from. So where are the interior angles that are far away from this exterior one? This side of the triangle, A and B. Another word could be remote interior, if that helps you remember it. So if we add together these two measures, we'll get this exterior, is what this theorem says. Highly likely to have you actually prove this, explain to me why this is true, either in homework or maybe even on, say, a quiz next week on Tuesday, or maybe on the chapter test. This explanation follows directly from the triangle sum theorem and doing some clever substitutions. Regardless, knowing this, we'll take this to be true, and I claim you can show this is true on your own. With this being true, we can actually set up some equations and find some angle measures. Like, say, find the value of x here. Oh, look, exterior angle. That means that 4x plus 8 better be equal to the sum of its remote interior angles. Best be equal to the sum of this angle and this angle, or 2x plus 3 and 51. Is an equation we're allowed to write based on the exterior angles theorem. Let's also solve. You get x is 23 if I'm not mistaken. Blah, blah, blah. So x 23. We can use a bunch of knowledge to help us figure out the three missing angles in this. And the exclamation points were typos. They're supposed to be degree marks, but the computer typed it. Okay. These are supposed to be degree marks, not exclamation points. Okay. It's not supposed to be exciting. It's just an exclamation.
Exciting
Well,
thing.
I like it better like this.
Sure. Anyways, if we want to find these missing angles, well, I see two triangles. I see a triangle here where I don't know two of the measures, and I know a triangle here where I know one. I know two of the three. Well, let's find one angle measure we definitely can calculate. What's one of them we definitely know? Spencer? Okay. Angle 2 must be 30 degrees, because angle 2 and 30 degrees are vertical angles. So 2 must be 30. What's another one we definitely know?
Oh yeah, one. One. Yeah,
1 must be 60, because you know the sum of the angles of the triangle is 180. So 30 plus 90 plus what is 180? That's 60. Oh, and you could use that same idea. Sum of the angles of a triangle must be 180. 30 plus 70 plus what is 180?